Now that we've created the test notebooks, now it's time to create the code for training the models and performing the EDA. So first of all, we will create a new folder. We will call it training, and within this folder we will first create train utils.py. I will open up somewhere else. Yes. Now in train utils we're going to write all the utility code that will be used later on. First we have data underscore directory. We will store all our data in the data file. It's a data folder, so data. Next we have data underscore file underscore name. It was wine qt csv. Then we have data file path. It's going to be this only. Okay. Of course I forgot to import OS over here, so it's going to throw an error. Yeah. Next we have the app directory. App here. App. Now we have the model directories. Model directory name, models, model directory equals app directory and model directory name, model name equals, for now we'll write default model .pkl, and now let's use joblib here. So I wanted to show you joblib, so I'll do that. Next we have model path, OS, model directory and model name. Yep. EDA directory, OS dot path dot join app directory, and then we have data. EDA path, we will write artifacts dot joblib. Then we have EMA path, OS dot path dot join. We have EMA artifacts. Great. Next we are going to create the code for train model. To create train models, we will just train model dot py. We will create this code. First of all, let's just import everything. Import pandas as pt, import numpy as np, import joblib import OS, import system. Next we need to import our project settings. So from training dot train underscore utils import. So we have data file path model import till here. That's it. And next we have from sklearn. I'll just get it all from the previous code that we've written. That's the best part about using the existing code. Since I've already worked on the EDA and model creations, I already know what all code has to be imported. But here we are just going to make sure that it is reusable. We'll create functions and we will try to follow a proper guideline for coding these things. So we will write def. First of all, we will load the data. So load and clean data. And that's it. And we will just paste it over here, the ones we've created before. So what it's doing is it's going to read the CSV file. It's going to throw an error that the file is not there in this particular data file path if it happens so, which it will. If we run it right now, we will see that there is no data, so we'll have to move this file over here. We will create a new folder called data. We will paste it over here. Yes. Next, it's going to drop this particular column ID since it's irrelevant to us. Then we ensure the quality is an integer. And then we will drop the duplicates. This is what we did last time. Next, we're going to create def train models. We are not just training one model, we are training multiple models here. So we will first of all print this. So what we are doing is we are defining the model architectures here first. Random forest, XGBoost, light GBM classifier, cat post, SVC, and we are also tuning it based on the tuners that we have found in Optuna in the last video. And these are here. Next we are going to train model. So for that we'll create a dictionary first and then run the loop. So it's going to run the loop through these items and model blueprints. It's going to check the name and the model, and it's going to print this name over here. And then if name is XGBoost, so if it's XGBoost, then the Y train will be Y minus 3. So basically we want 1 to whatever the output is. And then what it's gonna do is model. This will be the model, so it will try to fit the data in it. So X is our data set and Y is the label, or should I say the quality of the wine. And then we will train it. We will store it, train models, and the name will be stored over here. and then we will print it. In this particular dictionary will be returned, and next we are going to save the model. So def save models, we'll import trained models. That's it. So we'll write print saving the models. That's it. Now to run this, we first need to add a file called init.py. I think I missed something. Yeah, it's not py, it's py. Yeah. Now we will just run it. That's it. All set. Now we'll run it, and we will have something like this. Yeah, you can always check in app we'll have models, and within models we'll have all these things. Great. Next we will create the code for performing the EDA, as well as then after that we will create the code for performing the model analysis. Next we will make another file. We will call it perform eda.py. It's important that you take your exploratory data analysis out of the notebook and store it as a Python file. So first of all, we will import everything that we need. So I'll just get this from previous one, and then paste this as well. From SciPy stats, we need to import the scores, import plotly, because we will be doing a lot of things. First of all, let's define the helper functions. So we will get data inspection setup, and then we'll write if regional, and then so basically its process is to analyze the data itself. So we will write this, and then first of all we will like to do this, and then we will write a code which will and this is the comment. So basically these things are for the front end. You're not trying to create something new. It's just we need to work with the front end as well. So your exploratory data analysis, the thing that you were able to see in the website, in the front end part, it's that. Next we will write a code for get target distribution. So step 2 is target distribution. It will just print something like this: processing setup, target distribution. It will check the quality, the value count, sort, then sort the index, and then it will just plot things out here. I am trying to keep things as dynamic as possible, so this way you are able to observe if there are any changes in the data set. Then get correlation heat maps. Then we have aux plots. I've explained mostly all of this, whatever the output was in here. Here. It's all just that. Next we have feature distribution setup. Next we have get outlier analysis setup. So if you look at the code, it's mostly what's happening over here. Then we will get feature profile setup. You can simply copy this from my code. And next what we're going to write is the code for interactive plots. Let me explain this to you first. So we have defined this particular scatter plot, and then we will just write the code to show it. Then we have add function to get the feature importance. Now that we have all these things done, what we had already performed over here, we will write out the main orchestration. We'll simply write generate EDA artifacts. So what it's doing is it's going to get the EDA artifacts from here. Of course, first the data file. If the data file is not there, of course it's not going to produce the EDA, but when it does, it will execute all these steps one by one. How is it going to do it? It will first append current df, step 1 clean df artifacts, and then it will store it in full data, and then this particular artifact's full data will be given up in the next one. So see here, current df EDA sections, sections will just keep appending to it, and when that is done, it will save everything. Next we have this right here. We'll save it. I'll try to run this. Perform EDA. Yeah, this should be working. Now that ED artifacts are ready, you can see it in app, data, there. All the artifacts are ready over here. Now that when we are going to write the front end, it will be able to read it. Similarly, now we are going to create the perform model analysis. We will create another file, perform model analysis.py. We have this to import first. So these are just the basic thing. Also we've imported warnings over here to write up any warnings that we want. Then we have these things to measure. We have kappa score, and then we also have the models over here. For optimization, we are going to import Optina to mute unnecessary warnings. We will use these. First function is to load the data. Then next is to verify. So first step is to verify the stratification. So we will use this code over here. So what it does is it's basically getting the data, it's writing the stratified k-fold, and it's trying to train it, and then it will just return all these values that of whatever we get. Then we will create the baseline. It's like a tournament. All the models will be trained and they will be scored, and then we will see what happens before tuning. Now we will use this. So once we've defined all these, it's going to check the classifiers, it will iterate through it, and then we will also check the regressor strategy. It will iterate through only one of these, and then the results will be added to the models, and then it will return whatever the data it has been calculated. Next is tuned model evaluation. So we'll get the values from the past tuner that we've created. So what's happening here is objective factory, it's going to check the models. It's gonna go through each iteration. It will try one by one, and then when that is done, it will find the evaluation and it will store it in this kappa, and then it is going to append, like change the weights and check and everything. And when that is done, it will save the model in the variable itself. Now we have this run tune tournament. Again, this is to show the result. Now this is the main orchestration, so we'll write and in the end we will run it all. This one usually takes a lot of time, especially given what kind of hardware capabilities do you have. It will totally depend on that. Okay, so we have all of these things done. The tournament is done, and the model artifacts are now saved to the data folder. If we check, yeah, EM artifacts are as well saved. Next, we are going to create the cache systems so that every time a person is loading the weights, it doesn't necessarily have to load it every time from the server. They can store it in the cache once the values are run. It's there, because every time running the data is running the model is going to be an expensive process. So what we're going to do with an app, we're going to create a folder called cache, and within cache we will write redis underscore cache.py. Now within this we will import JSON, then we will import Redis. We will from app.core.config import settings. Then we will write Redis client equals to redis from URL. We will write your response true. Yeah. Next we are going to write the function. So def get cached prediction, and then key star, close it. Next value, get key. Now if value, then return json.load.value, return none. Yeah, this looks good. Next is set cached prediction, the key is string, dictionary, inspiration, and 3600. Yeah, that's good. And then Redis client set key JSON dumps, and then value expiration. Or we can just write expire. Yeah, great. Now this is set. Next we will create the model services. Its job would be to not only predict but also to check if we have already stored the value that the user has given us, and then we will load that particular instance. So within app we need another folder. We'll call it services, and within this we will create a file called model underscore services .py. Yeah, it's there. As usual, we will import job lib, then we will import pandas as pd, we will import os, we will import json, import hashlib from app.core.config import settings, that's right, from app.cache this cache, get redis cache and predict. Yeah, exactly this. So once we're done with the reporting, we're going to first of all create a global in-memory cache for loaded models. So just write it out here like this. Global in-memory cache. So we're going to write loaded ADT underscore models. We'll store it in this, and then def get model path. We will pass on the string and it will output a string as well. So file name map equals, first of all, default, and then we will write the default model dot job lib. So next is random forest there is no model here, just job lib. Similarly like this, simply paste it over here. Yeah, that's it. Next we have file name equals file name map get model name, and by default I would like to pass on this. So if not file name, then we will raise error that and otherwise we'll just return os.path join settings.model.dir file name. Yeah, this works nice. Next we've got to create EAF generate cache key, not the whole, the data. It is a dictionary, and then model name, that will be a string, son string, then data str json dot and return if predict. Yes, that's exactly what I wanted. Next, we are going to write the prediction function. Next, we're going to create the function to, here, def predict wine quality. It's going to receive data as dictionary. And then model name, string. I don't want to pass on a default as of now. So first we're going to check if there is any cache. So try cache underscore key equals generate cache key, data and model name, cache result, get cache key prediction, cache key. If cache key result is not none, or we'll just say if cache result, we'll just simply first of all print returning cache result, and then we will return it. If not, exception as E, print error accessing cache, and then the E. Next, we're going to load the model. So we are only going to load the model that is not in use. So if model not in loaded models, try model path as get model name, and here we're going to write if not OS path accessed model path. Then we are just simply going to print, or rather raise file not found error, model file not found. And then if not this, then we're going to write print loading model from this path, and then we're going to write loaded models chocolate.load. Now except E is an exception E, and then we will raise runtime error, model name is not there. Next we have model loaded models, we will load the model name. Next we are going to prepare the data. We will convert the input dictionary into a data frame. So input df is equals to df.dataframe.data, and then first of all we'll do the column mapping, column mapping, then we will write all the columns over here, and then we have input df.rename columns. Next we will predict whatever we have given as an input. Try prediction output model.predict input df in the 0th input, raw value equals float prediction output And then like, so if it's a regressor, then we need we need to round the we need to round the float value. So if it's a classifier, then we can directly return the int, but round is safe for both. So final quality equals to int round raw value, and then except he has an exception, error during predictions. Next we're going to save to the Redis. We will try cache payload equals, we'll create a dictionary model name, then we will have prediction quality, we will have final quality, and in the last raw value float raw prediction so I mean this is optional, so nice for debugging. This should be raw value. Yeah. Now set cache prediction, cache key, cache payload, and then we will write exception as e, print error settings cache, and then finally we will return final quality. That's it. Now this is done. We will save this, and next we'll move on to create the endpoint which will receive all the inputs from the user. So we will go to, I'm sure there was supposed to be an API thing. We will create a folder called API, then we will add a file called roots underscore predict.py. Awesome. So first we're going to write from FastAPI import API router depends, and also HTTP exception. Then from FastAPI, rather pedantic, import base model from app.core dependencies. We will import API key. Get API key. Next, from app.services dot model services import predict wine quality. That's right. Router equals API router. First, we'll define the input schema. So class wine features. We will write base model. What else is missing? Awesome. Next, we are going to update the route. So we'll add router, post predict, post predict, and then just write model name. Yep. Then we will write def predict quality. First of all, it will have model name as a string. Then it will have wine features, and then depends get API key. Once that is done, then we will say try. Next, we're going to pass both arguments to the service. Prediction it'll start predict wine dot model dump and then model name. After this, we will return two things, basically a dictionary, but within it we will have model underscore used, we'll have model name, and then prediction quality prediction. That's it. Next, we will raise an exception if there is an error. Raise HTTP exception 400 over here. When the model isn't found, here value error, yes, exception, then it is 500. So that's it. This is how we will create and set up the services for predicting the model, using the model to predict the data.